Hey, now on the screen, I have the 2023 Singapore Cambridge GCE O-Level Additional Mathematics Syllabus 4049, Paper 1, Question 9. Now I'll be looking at Paper 1 of the 2023 exam this time, and Question 9 is a differential calculus question. Now a curve, we're going to look at, what we're looking at here is a cubic curve. So it has equation y equals to 1 plus x minus x squared on 2 minus 2x cubed. Find the x coordinates of stationary points A and B on the curve. Now I'm going to do a bit of sketching. A negative x cubed graph will look something like this, with a minimum and a maximum here. The x and the y axes is A and this is B. So in this case, what to do? Find the derivative of y. So differentiate 1 equals 0. And this is 1. Power is subtracted by 1. So I have x minus 2, 3x squared. So I'll have 1 minus x minus 6x squared. Now, at the stationary points, my derivative is 0. In other words, the tangent is just a horizontal line. The gradient of the tangent at the point is 0. So what I have here is 1 minus x minus 6x squared, which is 0. I'll do this. My coefficient of x squared has to be positive in order for me to factorize it. So I have 6x squared plus x minus 1 equals to 0. Then I can go on to factorize it. I have 6x squared minus 1 plus x. So 3, 2, 1, 1. So I'll have 2x, 3x, and yeah, I have this one. I factorized it, and then I'm just gonna solve for x. 2x is negative 1. X is equal to negative half. Or x is equal to 1/3. They're asking for the x coordinates, so just gonna give this it is. So the x coordinate they are negative half and 1/3. And this is part A. Part B. It is given that P is a point of the curve where the gradient is a maximum. Show that P and the midpoint of AB have the same x coordinate. So when the gradient is a maximum, the gradient in this case I'm referring to the derivative, and it has to be a maximum. It has to be a maximum. So you may have heard in your lessons in calculus, when you're doing differential calculus, that when a point is a maximum or a minimum, then the derivative has to be 0. In this case, the gradient is a maximum, then it's not right to assume that the first derivative is 0. In fact, it is the second derivative. So I'm going to find the second derivative. It is differentiate 1, you get 0. It is negative 1 minus 6. It is negative 1 minus 12x. Okay. It is roughly the same idea as, let's say, the point is a maximum then my derivative is equal to 0. In this case, when the gradient is the maximum, then my second derivative has to be 0. Same concept. Now, when the gradient is a maximum, then my second derivative is equal to 0. So -1 minus 12x gives me 0. Then negative 12x 1. And then I can find x. So in this case, the x coordinate of P okay, then what I can do from part A, I can find the midpoint of AB. The x coordinate of midpoint of AB, which is -12 plus 1/3 over 2. Which is -1 over 12. Okay, since this is a show question, I will be a bit more cautious, and instead of just presenting my answer straight away, I'm just gonna do this. Okay, nice. So since the x coordinate of P and the x coordinate of the midpoint of AB are both -1 over 12, P and the midpoint of AB have the same x coordinate. Same x coordinate. And there we go. And yes, this is question number 9 of the 2023 paper 1.